Hi, it's Mr. Royks. I wanted to make a video for the students that may have had some difficulty with this last quiz. I'm going to take you through how to answer each of these questions, and hopefully you can see where you made mistakes. I will point out where some of the more common mistakes were. So again, first thing is, in this first reaction we needed to balance it. So if you go through balancing, and I think a lot of people recognize that all you needed was a 2 in front of the HCl. So now we have 2 hydrogens on this side and 2 hydrogens on that side. Everything else is going to be left at 1. In this particular question, it tells us we're given 0.42 moles of calcium carbonate and 0.33 moles of hydrochloric acid. And we're asked to figure out how much water forms. So in this particular case, right, since we're already given our values in moles, we're already going right to the mole-to-mole ratio. So we don't have to convert these to grams. A lot of people thought immediately and were trying to convert the moles to grams, and then potentially, if you did it properly, you could have converted it back to moles in order to solve, but you don't even need to do that. Once it's in moles, it's the mole-to-mole ratio. So we can set up two expressions. We're going to start with the 0.42 moles of calcium carbonate, right? And we're just solving for moles of water. That's all this question is asking for. So now what we need to do is we need to figure out what's the ratio of calcium carbonate to water. As you can see, it is a 1-to-1 ratio. So since it's a 1-to-1 ratio, we would say for every 1 mole of calcium carbonate, we would have 1 mole of H2O. A lot of people were trying to split up the calcium carbonate and solve for oxygen, or split up the water, solve for oxygen. Don't do that. Don't do that. All you're doing is looking at the mole-to-mole ratio. It's a 1-to-1 ratio, so the answer is just 0.42 moles of H2O. Going to do the same thing for the hydrochloric acid, the HCl. It's 0.33 moles of HCl. The ratio is going to be, in this particular case, right, we're solving again for moles of H2O. So HCl goes on the bottom, H2O goes on top. What's the ratio? Well, look at your balanced reaction. It's a 2 moles of HCl to 1 mole of H2O, right? So in that particular case, our answer comes out to be 0.165. Look at these two values here, right? The lesser amount is our limiting reactant, and that tells us how much water can actually form. So our answer is going to be the 0.165. Now again, different quizzes had different values to start with, but the process is the same for all the quizzes. So that's question 1. Question 2, if reaction between butane and oxygen gas forms carbon dioxide in water, right? So they give you the values there. Here, very important, you need to write a balanced reaction. Many of you did this. A couple people missed that, but most of you did this. It's C3H8, right? If it's combusting, that means it's reacting with oxygen gas. It is going to form carbon dioxide and water. And then to balance this, we need a 3 in front of the carbon dioxide. We need a 4 in front of the water, and we will have a 5 in front of the oxygen for that balanced reaction. So now, in this particular case, since they're giving us grams, we have to convert to moles. You can't do anything with the grams. So we're going to start with our 3.5 grams of butane. We need to get it to moles of butane so that we can use that balanced reaction. So the molar mass of butane, is 44 grams. So it's 44 grams per 1 mole of C3H8. All right. Then we're going to look at the balanced reaction. Again, we're asked to solve for grams of carbon dioxide, so we know we have to go back to grams. but before we can go back to grams, we have to look at the mole-to-mole ratio. Right, there are 3 carbon dioxides for every 1 butane, so we'd say for 1 mole of butane, there are 3 carbon dioxides. And then since we're solving for grams of carbon dioxide, right, we have to convert our carbon dioxide back to grams. So 1 mole of CO2, and it just so happens that CO2 has the same molar mass as butane. It is 44 grams per 1 mole. So when we multiply this through, obviously the 44s would cancel each other, and it's 3.5 times 3, which is 10.5 grams of CO2. All right. Then we need to do the same thing for the 15 grams of oxygen. So it's 15.0 grams of O2. All right. In this particular case, very important. A lot of people made this mistake, right? It says O2. O2 means that we have to multiply the mass of oxygen by 2. So it's actually 32 grams per 1 mole. Okay. Then we're going to, again, look at the mole-to-mole ratio. We're in moles of O2 right now, and we need to convert it to moles of carbon dioxide. So we'd say for every 1 mole of O2, and I'm already messed that up, this should be 5. For every 5 moles, that's a 5, sorry, moles of O2, there are 3 moles of CO2. So it's a 3 to 5 ratio there. Again, since we're solving for grams of CO2, we need to, now that we have it in moles of CO2, convert it back to grams. So 1 mole of CO2 has a mass of 44 grams. When we multiply all of that out, we're going to get an answer here of 12.37. Remember that your quiz might not have had the same values in here, but again, the process is still the same. What's not going to change is basically this middle section here. You might start with different values at the beginning, might end with different values, but this middle section, no matter what quiz you have, you're going to be doing the same process to solve. So you can go through and check your work on that. Again, we look at these, compare these two values. The lower value means that we are limited by the propane, okay? And this is propane, not butane. That was, again, an error, a naming error, but this is propane, so we're limited by the propane. We're going to run out of propane first, and we can only form 10.5 grams of CO2. Last problem. Last problem was a combustion analysis. And I'll take you through this right now. So in this particular case, we're given the mass of the entire sample of this unknown compound. The unknown compound contains carbon, hydrogen, and oxygen. So we need to solve for each of those. It tells us we produce 1.832 grams of carbon dioxide and 0.750 grams of water. Now, in this particular case, we know that all of the carbon in the carbon dioxide came from our unknown sample. We know that all the hydrogen in water came from our unknown sample. However, we don't know how much of the oxygen came from our sample and how much was actually from the atmosphere. So how much was used from the atmosphere. So what we have to do is we have to solve for the carbon, solve for the hydrogen, and then look at the difference between the total sample and the masses of those two atoms or elements, carbon and hydrogen, and the remaining is going to be the oxygen. So here we go. We're going to start with our carbon dioxide. We're going to use this mass of carbon dioxide to solve for the amount of carbon that was actually in the sample. So we're going to say 1.832 grams of CO2. We need to convert that to moles of CO2. So we'd say 44 grams is 1 mole of CO2. Okay. Then we want to get it to look at the ratio of carbon in carbon dioxide. So for every 1 mole of CO2, there's only 1 carbon, so 1 mole of carbon. Okay, and we can solve for the number of moles of carbons. I'll show you why that's important later, but we're going to actually do the math here, and we're going to solve for this to be 0.0416 moles of carbon. Since the sample is a mass, it's in grams, we have to convert the carbon now to grams. So for every 1 mole of carbon, the mass is 12 grams. So then we're going to multiply that out, and that comes out to be 0.4996. Okay. Then we're going to do the same thing for the water. We need to solve for the hydrogen. So we have 0.750 grams of H2O, right? We're going to say that H2O, 1 mole of H2O has a mass of 18 grams. Okay, now we're going to convert to moles of hydrogen. So for every 1 mole of H2O, how many hydrogens are there? There are 2 moles of hydrogen. Okay, we're going to solve there. If we multiply that through, this comes out to be 0.0833. And that's moles of hydrogen. Again, we need to get it to grams of hydrogen. Now, notice that this is just hydrogen. This is not H2 at this point. This is just H. So 1 mole of H has a mass of 1 gram. So our mass of hydrogen is 0.0833 grams. I'm sorry, this is grams of carbon. This is grams of hydrogen. All right, so now that we have the grams of hydrogen and the grams of carbon, we need to look at the difference between our sample, our 1.2500, and these 2 masses. So we set up a quick problem here, and we say 1.2500 minus the sum of the mass of the carbon, 0.4996, plus the mass of the hydrogen, 0.0833, and we're going to solve. And when we solve for that, that is going to be the mass of the oxygen in our sample, 0.666 grams of oxygen. Okay, then what we're going to do is we're going to convert our grams of oxygen to moles of oxygen. So if we convert our grams of oxygen to moles of oxygen, right, what's the molar mass of oxygen? Hopefully you know it's 16 grams per 1 mole. So we're going to do 0.666 divided by 16. If you do that, you come out to an answer of 0.0416 moles of oxygen. So now that we have that, we want to look at the moles of each of these. We have 0.0416 moles of carbon, we have 0.0833 moles of hydrogen, and 0.0416 moles of oxygen. So to get the empirical formula for this compound, what we're going to do is, again, divide by the lowest number of moles. What's the lowest number of moles? It's the 0.0416. So if we divide carbon by that, it tells us we're going to have 1 carbon. If we divide hydrogen by that, right, you'll notice that that is twice this value. So it's going to be 2 hydrogens. And obviously, if we divide oxygen by that, it's just going to be 1. So the empirical formula is CH2O. And that's how you solve a combustion analysis problem. Hopefully, this helps you, and you can kind of look through your quiz and recognize where you made mistakes, so that you're able to do this going forward and on the test. We'll see you in class.